Hello everyone, welcome back to Array blog once again. So in the last video, we learned about array operation, vectorization and broadcasting. And in this video, we'll explore array manipulation in NumPy, including reshaping, transposing, stacking, splitting array, and the difference between copy and views. So let's get started. And what we'll do, we'll create a file that will say array operation .py, right? So what we'll do, we'll import the NumPy first, NumPy as np, and then we'll create array equals to np dot array, and we'll say 1 comma 13, right? And we'll print this first. So we'll say original array and then array, right? So what we'll do, we'll print this. So we'll say python array operation.py. So cannot, oh, we did array, so we have to use arrange so that we can create a one dimensional array, right? Still there is a issue. Okay, we have used the double R. We haven't say, so we've created an array that contain the value of 1 to 12, right? Now what we'll do, we'll reshape this. So what we'll do, we'll reshape. For the reshaping, we know that we'll create a array that reshape equals to array dot reshape, right? And we'll say create 3 by 4, and we'll print this and say reshape array, and then we'll write this array reshaped, right? Now let's run this and we'll see. So we created here 3 by 4 array, right? Now the next one, what we'll see, we'll create a flatten array. We will say flatten array, right? Now the question is, what is flatten array? So flatten array creates a new 1D copy of the array, right? So let's create this. So we'll say print flatten array, and we'll say array dot array reshaped dot flatten, right? And we are going to print this. So we'll run this. See, so it's created a new 1D of the array, right? First we have the original array, and then we convert it into the 3 by 4 dimensional array, and then we again convert it into 1D array, right? So there is another one that is called reveal, right? So for that, so reveal basically return a flattened view whenever possible, because and it's also save the memory, right? So print, we'll say flatten array, and then we'll say array dot reshaped dot array level, right? Now we'll run this again and see, we got this again, right? So basically reshape change the shape of an array without changing data, and flatten create a new 1D of the array, and Ravel is basically return a flattened view whenever possible, saving memory, right? Now what we'll do is we'll create a transpose of a array, right? That is basically mostly used in a matrix and linear algebra. Transpose array. So what we'll do, we'll create an array. They'll say array 2d equals to np dot array, and then we'll create the array. So first value will be to 1, 2, and then 3, and then we are going to pass the value again, that is say 4, 5, and 6, right? Now we are going to create a transpose of array. So first we'll print the original array. So we'll say print, that is original array, then array 2d, and we'll again print the transpose array, right? So but before printing this, we have to convert it to a transpose array, right? So we'll say array 2d dot t, right? And we'll print this, print array transpose. Now we'll clear this and we'll run this. See, so we have created the array here. What you can do, we can just type the message here so that it will be clear. So transpose array, right? And then comma. So we'll clear this and we'll run this. See, so here we got the 2D array, the original array, and then we convert it into the transpose, right? So basically transpose, what it does, it switches row and column, and it is you know, if you have learned about matrix and matrix in your 10th and 12th classes, so it is mostly used in matrix and linear algebra, right? Now what we'll do, we'll start the concatenation again. So we'll see some concatenation in a NumPy array. So we'll create array 1 equals to, that is np dot array, and we'll create a 2D array. So 1, 2, 3, or we will just use the 2-dimensional array, and then 3, and then 4, and for array 2 equals to np dot array, and we'll use again this, then we'll say 4 and 5, or we can say 5 and 6, and then we can say 7 comma 8, right? And it is going to be array 1, right? Now what we'll do, we'll concatenate this first along with x-axis. So we'll say along with axis 0, right? That is basically rows. So we'll say concat 0 equals to np dot concatenate, and then we'll pass the array 1 comma array 2, and we are going to say, get the bracket here, and we are going to say x is equals to 0, and we'll print this. So print say con, and it's print, and then we'll say concatenate, right? And then we'll say concat 0. So that is going to give us the value of concatenation of two arrays. So here we go, we get the 1, 2, 3, 4, and then 5, 6, and 7, 8. So we concatenate the two array along with axis 0, right? And row. So what if we have to concatenate along axis 1, that is column? So we'll say concat 1 equals to, we'll just copy this, right? And this is going to be axis 1, right? And this is going to be 1, and we'll say concatenate column. So we'll run this and we'll see what we get here. See, so we got 1, 2, 5, 6, and then 3, 4, and 7, 8, right? So 1, 2, 5, 6 is in a one element, and 3, 4, 7, 8 is one element. That's how you concatenate along with axis 1, right? Now suppose you want to stack all the array vertically, right? So for that you have to use base stack. So we'll create a variable that is base stack equals to np dot v stack, right? So you'll use this and then we'll pass the array. So array1 comma array2, right? And we'll print this. So print, that is we'll say vertical stack, and then we'll print here v stack, right? Now say run this. See, we got the vertical state. It's say 1 2 3 4 5 6 and 7 8, right? And suppose you want to stack the array horizontally, right? So what you have to do, you have to say h stacked equals to, let me copy this and then I'll print this. So we have to say h stacked, right? And then this is going to be horizontal stack, right? And this is a h stack. Let me copy this here and paste it here. Yeah. So we'll clear this and we'll run this again. See, we got the 1 2 5 6 and then 3 4 7 8. So basically NumPy allow combining array using concatenation, that is a stack concatenation, right? And concatenate and stack function. So access 0 is basically select along rows, axis 1 basically select along column, and v stack and s stack are shortened for vertical and horizontal stack, right? This is for the horizontal stack and this is for vertical stack, right? Now what if we want to split an array, right? So we'll just comment this and then we'll start again. So let's say array equals to np dot arrange, right? And 1 comma 13 dot reshape into 3 comma 4, right? So we're creating a one dimensional array and we are reshaping it. So we'll print this, print original array, and then we're going to say arr, right? So we'll clear this and we'll run this. So we write this again and then we'll run this. So we got the shape of array that is basically 3 by 4, right? And now suppose you want to split into two array along column, right? So what we'll do, we'll say split arr equals to np dot split, right? And we're going to pass the array and we'll say the 2, right? Because we want split into two array along column, right? Now we're going to print this. So print, so splitting an array along column, and we are going to say split array. So we run this. We did mistake here something. So split array, and then we said that array, oh sorry, so it's not split, it's h split, because we are going to split along horizontal and we are going to basically h split work that split horizontally, right? So we'll run this and we'll see. We got this 1 2 1 2 5 6 and then 9 10, right? 1 2 5 6 and 9 10, and then second one is going to be 3 4 3 4 7 8 and 11 12, right? Now suppose you want to split into three array along rows. So we'll say split array underscore rows equals to, oh, we are writing this the wrong place, control X. See this. So let me clear this and we'll come back here, we'll write here. So split array and then rows equals to, so it is going to be np dot v split, right? V split, and then we'll say array, and then we'll say 3, right? Because we want to split into 3 array along rows, so we'll say print split along rows, right? And we'll pass the split array rows. Now we'll run this and we'll see what we get here. See, we got the 1 2 4, 1 2 3 4 5 6 7 8 and then 9 11 12, right? So NumPy allow us splitting array. So the first one is like h split that we use here. Basically, it is split horizontally and like a column wise, and v split that is split vertically, that is row wise, and the split that is general purpose, splitting along any axis, right? So split, and that's a general splitting along any axis, right? Now we are going to see the final one, like a copy versus view. So we'll comment this, and we'll come back again and we'll declare a array equals to np dot array, and we'll create an array that is that contain the value 1 2 3 4. That could be anything, right? So now we're going to say view. We are going to see here the view. First we'll say array underscore view. So we'll say arr dot view, and we'll make a function this, and then array underscore view, and then 0, right? And that is going to be 100. Now what we'll do, we'll so we'll print this first, and I'll explain later what I'm doing here. So print original array after view, and we'll say arr. Now let me write for the copy also. So arr underscore copy equals to arr dot copy, right? And copy 1 equals to 200, and we'll say print original array after modifying it, right? Yeah, yeah, we can say it, modifying it, and we'll pass the array. Yeah. So now let me explain what we are doing here. So the view here basically create a view of the array. So changes reflect in the original array, and the copy here create a separate copy leaving the original array unchanged. So let's run it and see what it does. See, it's a original array after view, that is 100 2 3 4, because we are replacing the zero zero index value, right? And we are just replacing this. So view create a view of the array, so change reflect in original array, right? So we can see the changes here. Now the copy, basically what it does, so copy original copy after creating an array, so it create a separate copy leaving the original array unchanged. See, so we can see the array is not changed here, right? So understanding this is important for memory efficiency and avoiding accidental modification, right? So you can combine reshaping, stacking, and splitting to manipulate data efficiently into real world real world task, and for data pre-processing and matrix operation. So in today video we learn about array reshaping array, that is a reshape that we have used here, that is a reshape. Yeah, reshape. Then we learn about flatten, then we learn about ravel, and then we learn how to transpose an array, right? So we learn how to transpose an array, and then we learn about split, h split, that is a h split, v split, right? And we learn about the difference between copies and view, right? So in the next video, we'll cover the statistical and mathematical function in NumPy for data analysis. So if you found this video helpful, don't forget to like, comment, and subscribe for more tutorial. So see you into the next one. Thank you.